Okay, so we're going to go through example 3 and 4 for section 0.9 data analysis. Example 3 says find the 5-number summary for the data set below. So that 5-number summary was the minimum, quartile 1, quartile 2, quartile 3, and the max. Those numbers we're trying to identify. And then we're going to do a second one where we will use that information in order to find some higher value, like finding the outliers. Okay, so this one, all we have to do is find the 5-number summary. In order to do that, these numbers must be in order. So there's a lot of numbers here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 30 numbers here. Okay, so we have to put them in order so that we can evaluate the list. So let's just start. Do we see any single numbers? No. So we're going to start with teens. I've got a 19, 19, 18, and I think that's it. So we're going to start with 18. I'm going to write kind of small. I've got 2 19s. Cross them off as you go or you will get lost. All right, let's see low 20s. I have a regular 20. Do I have a 21? 22? No. So 22s, I've got 1, 2, and that's it. So 22, 22. Okay. If I run out of room over here, I will jump into a second line, but I'm going to try and squeeze them all on one. 23. So we've got 1, 2, 3 23s. Any more? No. So 23, 23, 23. 3 of those. 24s. 1, 2, 3, 4, 5 24s. So 1, 2, 3, 4, 5. How many 25s? I've got 1, 2, 3, 4 25s. 2, 3, 4. I'm not sure I'm going to make it, but we'll see. 26s. 1, 2, 3, 4. Okay, so 4 26s. 3, oops, 4. Careful not to write the wrong number there. 27s. 1, 2. 2 of those, so I guess I am going to have to come down here. 27, 27, 28, 1, 2, 3, 29s, 1, 2, 3. So 29, 29, 29. All right. So we have to identify the minimum, quartile 1, quartile 2, quartile 3, and max. That's what they want from us on this problem. We normally will use those numbers to find our interquartile range and our outliers, but we just have to identify them in this problem. Okay, so we had 30 numbers, right? So our minimum, easy, that's 18. Maximum, and this was for the number of students in a class at a school, for each math class at Central High School. So if there's 30 numbers, halfway through is going to be between 15 and 16. But you can also count backwards if you're not positive. So we can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. So I'm in between those two 25s. The value for quartile 2 is right here, and it's 25. Quartile 1 will be exactly between this point and my 18. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2. This is quartile 1, 23. Quartile 3 is going to be 1, 2, 3, 1, 2, 3, 4, 5. I'm at that 26. 1, 2, 3, 4, 5, 1, 2, 1, 2. Quartile 3 is at that 27. Okay, and again, they don't ask us for it, but my interquartile range here is from 27 to 23. So 50% of the data happens between 23 and 27, and it only varies by 4 numbers. So outliers are going to be pretty easy to come by here. So in order to find an outlier, you take quarter 1, minus 4 your interquartile range times 1.5. Okay, so let's say, let me write that as IQR, and quarter 3 plus your IQR times 1.5. So in this case, we would take 23 minus 4 times 1.5. And we would get 17. So our lowest number here is 18. We don't have an outlier on that end. Here we have 23, Q3 is 27 plus 4 times 1.5, or 6, I believe. 33. We don't have anything larger than 33. So even though our quartile range, interquartile range is so small, and it seems like we have numbers that should fit in that range, there are still no outliers to this data. All right, let's look at example 4. Okay, the required work is here. Find the min, Q1, 2, and 3, and the max. All right, so example 4, let's see if I can. We are going to look at this data. We're going to identify any outliers in the data set and explain our reasoning. So we have to come up with the work that we did here. We need the minimum, the quartile range, the max, find if there's any outliers. Okay, that's our first step. Then we have to find for that data the mean, median, mode, range, and standard deviation. So all that stuff we did on the first 2 examples, both with and without the outlier. So it's telling us we're going to have an outlier. Okay, and describe the effect on the measure. What happens between these data? Okay, so the first thing we have to do is get this data in order. So this is fuel efficiency in miles per gallon of 16 randomly selected automobiles. So let's get everything in order. So hopefully you can see that. Okay, so if we put things in order, I see things from 13 to 51. So let's look at our teens. We have just 13. One fuel efficient car. So 13. Then we have 20s. So I have 29, 22, that's it. So 22 and 29. 30s, 36, 36, 34, 36, 31, 32. So I have 31 and 32. Those are my first 2. 31, 32. I have 1, 2, 34s. I know I've got at least 2 36s. I've got one here, another 36. I had 3 of those. 40s. 40, well, that's going to be the next one, so let's just write that down. 45, 48, 42, 44. So 42, 44, 42, and 44, 45, 48, and 51. Okay, then I find the best thing to do, let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 16 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got everything. Okay. we need to come up with min, max, right? Our minimum is 13, our maximum is 51. So my interquartile range will be 51 minus 13. Okay, so I'm going to slide this up because we're looking for outliers. That was our first goal. Okay. Slide this up a little bit. So 51 minus 13 is 38. Okay. We need to find Q1 and Q3 so we can figure out where the outliers are. Is it going to be 51? Is it going to be 13? Is it going to be more than that? So find our median. So we had 16, so we're going to be looking in an average. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2. So we are, quartile 2 is right there between those two numbers. So that means this number is included in this data. This number is included in that data. So let's find Q3. We have to find halfway between this and this. So 1, 2, 3, 1, 2, 3. We have to find the middle here. Quartile 3 will be 42 plus 44. The middle there is going to be 43. Okay. Quartile 1, 1, 1, 2, 3, 1, 2, 3. I'm exactly in between 31 and 32. So quartile 1 is 31.5. Okay, so I have Q1 and Q3. We can do this work up here to find our outliers. Okay, so Q1 minus the interquartile range times 1.5 looks like 31.5 minus our range was 38 times 1.5. So if I do all that at once, 31.5 minus 38 times 1.5. Whoa, hold on. Oh, hang on. Okay. This is my range, not my interquartile range. That's why. Back up the train. Okay, my interquartile range is between my quartiles. So it has to be 43 minus 31.5. Or 43 minus 31.5. Okay, 11.5. That makes more sense. So 11.5 times 1.5. So 31.5 minus 11.5 times 1.5 will be 14.25. So anything below 14.25 is an outlier. So 13 is an outlier. Okay, so outliers will be 13. Let's see if 51 is an outlier on the other end. So this will be quarter 3 plus the interquartile range times 1.5. Quartile 3 is 43 plus 11.5 times 1.5. So I'm going to cheat a little bit. 43 plus, that'll be 60.25. So this is not high enough to be considered an outlier. Okay, so only 13 is my outlier. So I have to do this data twice. I have to do it once with 16 data points, with every data point, and then once where I discount the outliers, and I'll have 15 data points. Okay, so with outliers, I was instructed to find, in my instructions here, the mean, median, mode, range, and standard deviation. Okay, so mean, median, mode, range. Those are all easier to find here. This is just raw data with everything I have. So the mean here, I have to add everything up and then divide by 16. Okay, so 13, 22, 29, 31, 32, 34, and I have 2 of those, so I'm going to cheat and just say 34 times 2. 36, I have 3. Then I have 40, 42, 44, 45, 48, and 51. So be careful when you type. But we get 573 divided by 16. Let's calculate that. Yeah. And because there's not a whole bunch of decimals, I'm going to write all the decimals. So it's 35.8125. I may decide to change that later, but for now, it's not a non-terminating decimal. It does terminate, so I'm going to write down all the pieces. All right, the median is the middle number, which we found already here. So that is 36. The mode is the number which comes up most often. I had 3 36s, so it's also 36. And the range is the 51 minus 13 that I tried to use earlier, which is 38. So we have 35.8125, 36, 36, and 38. That's all the basic data. Then we have to find the standard deviation. So we need to come up with the, we have the mean. We need to come up with the differences from each of these numbers to the mean. So for my variance, we need to come up with, well, hang on. Let's say sums of x minus x bar. Let's come up with those. We can actually do it without the table. If you don't understand what I do next, make your table. But we know the mean. We will use the mean as 35.8. We will round it to the first decimal for this work like we did before. So I have 16 numbers. 35.8 is right here. So I need to take the sum, the 573, we added all this together and we got 573, right? So I can take 573, let me make sure I say this correctly, wait 1 second. Okay, so I was trying to think of a quicker way to do this, but unfortunately, because we have to square each individual number, we can't. So I made a table. Remember, we make our x, our data, x minus x bar, which is your average, or it was 35.8 for when we include 13, and then we will have to come up with a new table when we don't include 13. Okay, but for this one, we're going to use 35.8. And then we have to subtract them, so you take 13 minus 35.8, and you get negative 22.8. And remember, save yourself your effort, square it now, and you get 519.84, round it to 2 decimal places. Okay, do the same thing for each number. Okay, this is why you're only doing 4 problems in this section, because they are a little bit time intensive. That's part of science and math. It comes up sometimes. This is one of those sections. Okay, so 29 minus 35.8, you should get negative 6.8. We're getting closer to 0 here, so these squares are going to get smaller. 46.24. Okay, so keep working. Notice you have a couple of numbers that repeat here. We have to include them in the data that many times, but you don't have to do the work. We're just going to put the squares in here in just a minute. Okay, so I'm going to keep filling this in. You do the same and we'll come back. Okay, so I have my table completed and I have 16 numbers here. I've got to add all those up and divide it by 16. So you can kind of take a second and compare your numbers, make sure you're on the right track. But be careful when you're typing these in, because this can get really significant. If you want to, you can like add half of them and then add the other half to try and avoid a mistake. So let's try it out. 519.84, 190.44, 46.24, 23.04, 14.44, 3.24. There are 2 of those, so you can do times 2. 0.04, there's 3 of those. 17.64, 38.44, 67.24, 84.64, 148.84, and 231.04. Okay, so I got 1388.04, and I'm going to divide it by 16 to get my variance of 86.7775. Okay, then your standard deviation, that's what we were after, is the square root of 86.7775. And if you round that to 2 places, it should be pretty close to the same, if not off by a hundredth or so. But since it's there, I'm going to keep it as exact as possible. 9.32 would be a standard deviation. Is that what we asked for? Yes. Okay. So that was with the data. We have to also do it without the data, without the outlier. Okay. So this will be without 13. How does it change? I'm going to try and keep that on the same level so we can compare them. Without 13. Alright, so our mean, median, mode, range, those will be pretty easy. Unfortunately, our variance and standard deviation, our table will change because our mean is going to change. So no, you can't just leave that top one off and be done with it. So our mean changes. I wrote this down on purpose. 573 without 13 minus 13 is going to be 560. And how many turns? This is with 15 data points divided by 15. So 560 divided by 15 is going to be 37.3 repeating. So we'll use 37.3. Our median is going to shift. We are going to have a middle data now because we don't have 13 there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2. It is still 36. Our mode doesn't change because we still have 3 36s. That didn't change at all. Our range becomes 51 minus 22 because we don't have the 13 anymore. It reduces to 29. Okay, so now we're going to find our variance. Okay, so we found our variance and our standard deviation with our variance was 86.7775 and our standard deviation here was 9.32. So we'll come back to that in a minute. The mean that we're going to use for this will be 37.3. So it's a good number higher. Okay, so we're going to take a second and make our table with these 15 data points, find our variation. Okay, so you should get it by now. We're going to put in x. We're going to put in x minus x bar to find out our differences, and then we're going to square those so we can find our variance. And then once we're done with that, our variance will be our sum. Now we're over 15. Okay, so put in your data points starting with 22 now, 29, 31, and so on. Work on this table. I'll come in and kind of show you my first couple of differences, and then the squares will be up there. You can pause it, make sure your table is right, and then we'll talk about what the variance and standard deviations are. Okay, so I have completed the table. I took each number minus our new mean of 37.3, and I squared those. So now we have to go through and sum all of these up, add them all up, and divide them by 15. Okay, so take a second and do that, and I will be right back. Okay, so when I added everything up, I got 833.35. I have to divide that by the 15 data points that I have, and I get 55.56. So coming back in here, my variance is 55.56, and to find the standard deviation, we will take the square root of 55.56. So, oops. Remember how to get there. Second square root, that works on either of your calculators. 55.56 is 7.45. So, the standard deviation was defined as, where's my definitions? Let's read that. Our standard deviation is the average amount by which each individual value differs from the mean. So how tight that data is together. So what happens when we remove the outlier, because that was part of the question, it says describe the effect on each measure. So what happens to, when we remove an outlier, what happens to the mean? The mean, in this case, went up. Okay, so we removed a minimum outlier, and this increased, oh, sorry, you can't read mine. Okay, we removed a minimum outlier, and this increased our mean. What did it do with our median? No change, although it can change the median mode. It may or may not. We had no change in the median or mode. What happened to our range? Our range is smaller because we removed a value that was increasing it. Our variance is decreased. And the variance was the average of the squares of deviations or the differences from the mean. Okay, so that distance that each piece is from the mean is decreased, and in turn our standard deviation, which is the average amount that each value is from the mean, is significantly smaller. We went from 9 to 7. And I'm out of room. Decreased. So that's what they're looking for. You have to describe what is happening with each description of the value. In your problem that you work, the median or the mode might change. It just depends on the data and what you're working with. Okay? But this will allow you now to do 8 and 10 for homework. Like I said, if you want to turn in the first two, and you've already had those checked, great. If you want to turn in one at a time or a partial and say, hey, Mrs. Bruce, is this right? I will have them worked out so I can look partway through each problem. If we need to get together and talk about these individually, we might work on having a Zoom meeting later this week, but it's really a matter of taking your time so that you don't make mistakes and just following these processes. Okay? There is on the last page of the packet for this week, so you have these notes, you have the problems from the textbook if you don't have that to take home, and you have the worksheet that is just this section. I'm going to put up a separate assignment for just the 0.9 worksheet so that if you've got the other part done, you can turn it in and get it graded. And if you get this better than the old stuff, you can get this stuff turned in first. The only thing that we're doing this week is 0.9. I have decided not to give a quiz over 0.5 to 0.9. I just want to see you working diligently on the 0.9 homework and the worksheets from this section. Starting next week, we will begin, let me make sure I'm telling the truth, but starting next week, we will begin reviewing. We are not taking a final, but we will be, yes, we will be reviewing so that you touch base on each of those topics that we need to be reminded of going into either pre-calculus with Mrs. Tarr or algebra and trig, college algebra and trig, which will be with me. So we're going to do a quick review. We won't take a final, but you do need to complete those reviews. And they're going to be circuits, so you'll be able to kind of check yourself as you go along. All right, email me or message me with any questions, and we will get through this last bit of new material. And we're almost there, so keep working hard.